X and Y are two stars of equal mass. The distance between their centers is d. So we're given that on the diagram. Here's star X, here's star Y, and they both have the same mass. We're trying to work out the gravitational potential at the midpoint between them, so at point P. So in terms of the distances that we'll have, this distance from star X to P would be d over 2, and same for star Y to point P, that's also d over 2. Gravitational potential is given by this equation, V is equal to minus gm over r. So what we do is, gravitational potential is a scalar, so for the two stars, we work out the gravitational potentials at point P, again for each star, and then we just add the two things up. We don't have to consider directions, because these are scalar quantities. Scalar quantities don't have direction. We just add up the two negative potentials for star X and star Y at point P, and that will be our answer. So, for star X, the gravitational potential would just be minus gm, the mass is capital M, divided by the distance, which would be d over 2, times top and bottom of this fraction by 2 to get rid of the fraction within the fraction. The numerator just becomes minus 2 gm, and the denominator will now be d, and this is the exact same gravitational potential for Vy. Because for Vy, or rather for star Y, the distance is just d over 2, and the mass is just m, so the gravitational potential would be exactly the same. So when doing Vx plus Vy, finding the overall potential at point P, that would just be, so minus 2gm over d, and then plus the exact same thing, 2gm of d, so times it by 2 basically. That will give us minus 4 gm over d, and that will be c.